Today we'll be talking about something that I've been wanting to discuss for quite some time: AiOs and cooling loops and radiator mounting. I've been wanting to make a video like this for a while now, but the thing that really kicked it off was there was a user on Reddit that was having some issues with his cooling system in his home PC, and his cooling temperatures, his coolant temperatures, were running very, very high, upwards of 54 degrees Celsius, which is very hot, too hot actually. In cooling loops, cooling systems, AiOs, whatever, once the coolant temperature gets up to 40 degrees Celsius, you've pretty much lost your cooling ability. You're not able to effectively remove heat from the CPU. You need a good a good temperature difference between the coolant and the CPU, because that's part of the heat exchanges that's taking place in the cooling loop. The first part of it is from the CPU to the copper to your water block, and then from there you have heat transfer from the water block to the coolant itself inside the tubes and inside the block. And then once the coolant passes to the radiator, you again have heat transfer from the coolant to the radiator. So the issue that he was having was, let me grab, just for reference, in his system he had his radiator mounted up top, which is the optimum position, which I'll get into here in a moment. He had his video card mounted directly underneath it. On his board, he had an inverted board where his CPU was down low, very low, and his I/O ports were out front, in the front of the case, front being that direction. Well, he had his GPU mounted up here like this, directly underneath the radiator. And what was happening was he had his fans as exhausting out through the top, like you're supposed to. Actually, he had his mounted underneath, like that. But so it was drawing air from underneath up, and his GPU was discharging all of its heat directly into the radiator as those fans were sucking that air in from the hot GPU. So he could never get his temperatures under control. It was constantly remaining hot while he was playing games and putting it under load. He couldn't get it below 50 degrees Celsius. Even at idle, it was over 40, I believe. So that was an issue. I helped him out, told him to reverse the fans and make it to where they're drawing air in, and that fixed his problems. Well, what I'll get into on this one is particularly where to mount the radiator. You've got a few different options. Well, I'll back up a little bit. When they produce these AiOs, they're going to by default have a little bit of coolant or a little bit of air in the system. You can't get all of it out. It's very, very difficult. You can get most of it out, but the big reason why you don't want all of it out is due to overpressurization of the system. These systems don't get too hot. I started a European automotive service and repair facility, mainly working on BMWs, Volkswagens, Audis, and we would do lots of cooling system repairs. So I'm pretty well versed in cooling system functions with the water pump, thermostat, whatnot. Anyway, automotive systems run much hotter, upwards of 180, 190, sometimes upwards of 210, 220 degrees Fahrenheit. Well, the reason you don't want air in an automotive system is due to overpressurization. It'll cause the cooling system to start boiling because there's air in the system. There's an air pocket. And you can usually get air pockets stuck in your heater core, radiator, wherever, even the water pump. But anyway, back to the radiators. With these, you're going to have a little bit of air in the system, just so that when the system's completely filled with coolant to the top, once it gets up to temperature, you'll start to get a pressure rise. Well, you don't want these seals blowing out at each one of the fittings, or potentially the seams along the radiator, which is less likely, but most likely around here. Or even the O-ring. There's an O-ring that's mounted underneath the water block underneath the copper that seals it. And I'm eventually going to make a video about refilling these and replacing that O-ring. But yeah, that'll be for a future video. But so on these systems, you usually have about 2% air in the system. As they age, coolant inside of it actually evaporates through these lines. It will leave the system, and you'll slowly gain air and lose coolant in the system. It takes a long time. It takes a few years for that to happen. And the different quality of the tubing is a large factor in how quickly it evaporates from the system. High quality tubing, less evaporation. Just straight normal rubber, you'll have a faster rate of loss of coolant from the system and introduction of air in the system. Well, this is an old NZXT Kraken X73, I believe, or X63. So it's about, I think I bought this in 2012, maybe 2013, so it's about a decade old now. And as you can hear, there is air in the system, quite a bit. So I'm definitely going to be refilling this one at some point, topping it off. Probably replacing it with, I'm going to try a standard antifreeze, just a touch of standard antifreeze, mostly filtered water, either DI water, or I have a DI system for, or actually reverse osmosis system for my fish tank. So it works out perfect. Very, very clean water. The more contaminants in the system, you can have buildup around the pump, and that can cause issues. Well, back to the radiator mounting. How you have this oriented, the radiator mounted, depends on where the air bubble is going to be. Same as with the pump location. You want that air bubble, it will automatically go to the highest point in the system. It'll flow through it and end up at the highest point. These pumps, they don't run very fast. They usually run on average, I think, 1800 RPM, somewhere around there, 1900. Sometimes 14, depending upon the unit. Well, the rate or the force that bubble will rise through the system cannot be overcome by the pump speed. They don't move that much pressure. If you've ever seen bubbles rising through a fish tank, or when you're out swimming in a pool or something, bubbles rise very quickly. In a normal fish tank, a bubble can rise from the bottom to the top in a matter of 2-3 seconds, somewhere around there. So that force is very forceful, very quick. And that pump, these pumps cannot overcome that. So, say for instance you have your system mounted like this. Radiator up, pump down low. This is the optimum way to have it mounted. And the reason that is because the bubble will travel to the top, highest point in the system, and the bubble will be distributed, the air pocket will be distributed across the uppermost part of the radiator through these fins across the whole area. May get trapped in the end, may be a little bit there, but that's fine. Well, this is the way you want it. And the reason that is because the coolant being heavier, it will sink to the bottom, and your pump, it will be ensured to be completely filled with coolant all the time. And that's what kills these pumps. What kills the pumps is starvation of the coolant, which they rely on for lubrication and cooling. If you get an air pocket stuck in the pump because you've mounted it way higher, or say for instance, worst case scenario, you have the radiator down low in your case and you have the pump up high, this is a recipe for disaster. Because what will happen is the bubble will work its way through the radiator, rise up, and it will stay in the pump. And that pump will again be deprived of coolant for cooling of the pump itself and lubrication. You do not want that. If you have to, say, mount your radiator at the front of the case, such as this, with the tubes up top, this is a way that you can do it, but it's not the preferable way with the radiator up front as an intake. You know, fans blowing in that way, fans sucking air into the case like this. You technically want the tubes down. But say you do it like this. It's not that big of a deal as long as you keep the pump below the highest point from that radiator, from the top point, that's optimum. That's the best way to have it. The chances of having an air bubble get to your pump when it's below this top line, where that bubble is going to be up here in the end tank, the chances of that bubble being, again, forced to the pump, because the bubble will try to rise and stay at the highest point, since this pump can't overcome that pressure, the bubble will stay at the top of the tank, which is perfect. On these radiators, the way that they flow through, these radiators, they're actually split in two. You can't really tell, but so the coolant will come out from the pump, it'll push the coolant up to it, enter this half of this tank up here. It will then get, the coolant will then get forced down through the side of the tank, or side of the radiator, cross over from one side of the tank to the other, and then back up, and then exit out the other tube on the suction side of the pump. So it makes a loop, it makes a U-loop through the radiator. And the air bubble will typically get stuck in one part of the tank. So yeah, you want the bubble to get stuck up there. Now, granted, the bubble will be up there with, say, possibly on the suction side of the pump. It biases one side. I can't remember which side it biases most. I think it's on the, possibly on the pressure side. Again, yeah, and that makes sense. Again, because the bubble will go up in there, stay here, and the pump pressure is not enough to push it down. So it most likely, if memory serves me right, I may be wrong, I'll have to double check, but I think on the pressure side is where it stays, unless you've fiddled with the radiator to cause the bubble to move, and you've put it in the, on the discharge side of the radiator. Well, when it comes to other orientations, again, this is the worst position to have it, because the air will constantly find its way up to the top and will stay in the pump. This is horrible. Never do this. Some manufacturers have drawings showing the radiator at the bottom and the pump up higher. Do not do that. They're just using general stock footage just to add a neat image to their documentation. Don't do it. You can, again, have it mounted up front in the case, drawing air in, and as long as your pump is below this line here, you're good. You know, you can have it down here, have it even lower. Do not have it up above like that. That's recipe for disaster. Now, even better than this. Well, a lot of people complain if you do have it like this because of that little bit of air in the system. They'll usually have about 2% air in the systems is what they try to control as far as quality when they produce these AiOs. If you have it like this with the tubes up, you can run the possibility of hearing like a percolating or like water dribbling or like a little flowing water. You can almost hear that because of the burbling, gurgling that's happening up here with that air bubble. Well, as it's forcing air out into the tubes. With that said, the best way to mount it is actually like this if you're having it as a front intake. This way, again, the bubble's going to stay up top, but all of the coolant will continually stay low because of gravity, and this pump will stay submerged with water. You can have it, you know, close to the top right there, but preferably right here and lower, preferably. And it doesn't matter how far out, just as long as that line is below the top of the tank. Some people will say it's okay to have it like this, or a little bit above, like that, maybe a hair below. Keep it below. Just don't even risk it, because that's even, as your system gets air, as it gets air in the system, that air bubble will grow and your water level will drop. So what you think of as, oh, that's okay, that's right in line with the top of the tank, or in line with the center line of the tank. As your coolant level drops a little bit, you can get possibly an air bubble develop in the side of the pump. Possibly. Just to mitigate that risk, keep it below and you're good. Every time, all the time. Again, on the bottom, don't do this. This is preferable for an intake. You can do this and you won't have any issues. You'll experience some noise, possibly, might not. But the ultimate best way to mount these 100% all the time, every time, is like this. Again, that's because you're guaranteed 100% to always have coolant inside this pump. And that kind of gets into case flow, airflow. With the fans, you can either have these mounted as discharging like this, because on the fans, the cage section is always going to be your discharge side. A lot of times they'll put arrows on them. I don't know if you can see that, but it shows the direction of rotation and discharge. One way to remember, where the cage is not, where it looks like it's almost inviting you to stick your fingers into the fan, that's always going to be the suction side. So you can have it mounted like that, drawing air through the radiator and out, or you could have it pushing air into the radiator, push versus pull. Well, not to get too far into it with the fans, because I want to make another video covering even more information with fans and how they work, whatever. On these fans, you have fans which are primarily designed for static pressure or for overall airflow, overall CFM. And you can have, it's like a sacrifice of one or the other. You can have crazy high static pressure. If you want to optimize a fan just for static pressure, you're going to see a reduction in CFM. And likewise, if you want to optimize a fan for total air volume flow, CFM, you're going to have a reduction in static pressure. It's like a balancing act or a trade-off, one or the other. As you increase one, you're going to decrease the other. You almost can never have best of both worlds. Anyway, the big thing that determines the static pressure that a fan can have is with the gap that's between the fan blade and the housing up here. The larger the gap, the less static pressure it's going to be able to generate. And that's one way to identify a static pressure fan versus an airflow fan or a standard case fan. The fan blade widths are also a big identifier. The larger the fan width, the better it's going to be at generating static pressure. Think of the fan blade, the wider it is, as it's grabbing more air and able to force more into it versus a thin blade. And also with the static pressure fans, you'll also notice more blades. And what it comes down to is not only the gap between the blade edge and the housing, is how much space there is between the blades. The less space there is between the blades, the better it will be at generating a high static pressure. On the regular case fans, again, they'll be thinner blades, and they'll usually also run at, well, the RPMs don't really matter too much. There's a lot of variance with the RPMs, just fan design, whatnot. But kind of going back to the fans, static pressure fans will generally, almost like a vacuum cleaner motor, which is you can almost think of it as like a pump. Whether it's water or air, they're both considered fluids. Say, for instance, you study fluid dynamics in college, you treat air as a fluid. Pressure, volume, flow, it's like air. You know, move your hand through the atmosphere, you can feel it, wind blowing, whatever. This is a fluid, and it behaves like a fluid. Well, these fans, the static pressure fans, they will, in every instance, I don't care what the situation is, in every instance, they will perform better drawing a suction than they will blowing air through the radiator. Every time. Every time. And just like a vacuum cleaner pump or vacuum cleaner motor, you can actually see the manufacturers create what they call a pressure diagram, pressure flow diagram. And as the fans increase in speed, it actually ramps up and its efficiency starts climbing higher and higher until it peaks out. And then you'll get to a point to where overspinning it, you get diminishing returns and you get less flow without any change at all, if any, in static pressure. Well, again, they're always going to operate better, function better, and create the best amount of pressure difference, the highest pressure difference across this radiator, with it drawing air, sucking air from the radiator. Now, with that said, this difference between drawing air and blowing air through it, it's almost negligible. I actually was running some benchmarks on my system, trying to see if I could flush out a difference in the temperatures that it was causing, assuming that less airflow would cause an increase in temperature. I only noticed a 2-degree difference between the two, within the error of margin, just about, of run-to-run variance when benchmarking it or stress testing it. So again, the actual end results, the real-world experience, is negligible either way. If you're in a situation to where you have to have it as a pusher, it's not going to hurt the day. It's not going to hurt anything. In fact, you probably won't notice much of a difference. But me, being OCD, I've obsessed over it, and just knowing how pumps and fans behave, I'm always going to have it drawing air. Now, there's another benefit to this. When you have the fans mounted like this, drawing air through the radiator, when it comes to dust accumulation, which to me is the deal breaker on which way to run it, you're going to have air being drawn into the radiator from this side. Dust will accumulate on this side of the radiator. If you have the fan pushing through, the fan will draw air in, and you will have dust accumulation in between the fan and the radiator. Cleaning it will be a hassle. Every time you want to clean it, you'll have to remove the fans, and however you have the radiator mounted, on top of the case, in the case, inside or outside, it could be a pain to try to clean it. So as this fan draws air in, it just stacks it up and blows it at that radiator face, and it accumulates there. Drawing air through it, you'll have dust accumulate on this side, and it's easily, or more easily, cleanable. You shouldn't let it get that bad, but if it gets worse enough, you could almost peel off the dust from it like a layer, but it just makes it a lot cleaner. You just take the case outside, get some compressed air, blow it, get like a small, like a toothbrush or something very, very fine that doesn't bend the fins on the radiator, and it's much easier to clean. Well, so that's why I always recommend having it as a suction through the radiator like that. You can have it either discharging into the case. Say, for instance, you have it mounted at the front of the case. Optimum would be like this, blowing into the case. And again, if for whatever reason you have to have them mounted external like that, outside towards the front of the case, that's fine too. It's just going to make it a hassle to clean. You'll have to remove your fans every time you want to do that. Now, another thing that you can do, dual fans, push-pull, where you have both. Again, you're going to have to worry about your dust accumulation on the intake side of the radiator. So it's just going to be extra work that you'll have to do later on. Now, the benefit of doing a push-pull, what it all boils down to, you can pick all these different aspects apart, but what it's going to come down to is this enables you to run the fans at a lower speed and still maintain the same amount of airflow that you would at a higher RPM with just one fan. That's what it comes down to. So say, for instance, one fan, running at, say, 50% speed, 60% speed, this may be turning 1,000 RPM, 1,200 or so. It's going to generate X amount of noise, X amount of decibels. Well, you take another fan, mount it on the other side, you can then reduce the fan speeds down to, say, 500 RPM and have about the same amount of cooling ability. Temperatures will remain about the same as running that one fan. Now, one fan running higher generates more noise, right? So that's the big bonus with having two fans there. And I did run it. I ran this system actually in an old Case Labs case that I have. I ran it that way for quite some time just for the noise. My goal was to make the case as quiet as possible, and that was the way to do it. Very, very low decibels. The case was silent. The loudest thing in the system was the case fans themselves, and they were noctuas, and they're silent. So the case made no noise, just a slight hum, and that was it. But if I had ran just one, either as a pusher or a puller, and again, I would do the puller method like this, you'd get a little bit more noise out of it, especially under load. And again, that's the other thing. When you put it under a load, when you're playing a game, or benchmarking, stress testing, whatever, this fan is really going to ramp up and get loud. So in theory, you could run another fan as an intake, cut that speed in half, maybe 75% of it, and it's still going to be quieter. And you'll be able to play your game, do whatever you want, with everything still having still maintaining the same proper temperatures that it should be, but with less noise. Okay. Well, on these radiators, maybe I should have covered this a little bit earlier. Inside, you can see we talk about the divisions, how the radiator is really split into two. These top rows of horizontal bars inside the radiator, they're very, very small sizes. The diameter or the area inside of them is very small, so it pushes that coolant through there. And you've got the hot coolant coming in, and as it's running across those plates, it's exposing the coolant to the surface area of the radiator, of those plates. As the coolant's running through, it's hitting more and more surface area, transferring more heat into the aluminum of the radiator, of that bar. And then from there, the fins pull the heat away from the bars, and you have heat transfer, cooling. Well, coolant is having to be forced through there. And in theory, maybe it's too much for this video, but the longer the bars, if you were to say I was to take the length of this radiator and double the length, I may not experience any better cooling ability. May not, because after it makes its passes back and forth, there might not, in theory, be enough heat to have to be removed. All it's doing is creating more load, more pressure, opposition of flow for this pump to have to push through. So a huge radiator, you're going to get a major point of diminishing returns to where you're just overworking the pump with no real gain in temperature differences. So it's a balancing act of designing these things. Well, actually, I'll post up a video of the whole way the system works is very, very similar to a heater core in a car. You got hot coolant from the cooling system pumped into your heater core, and a blower motor mounted on the front or the rear, whatever, and it blows air over the radiator and discharges that air into the cabin to heat up your car during cold weather. Well, inside of these, it's not just a oval thin tube, it's actually divided into little square sections. I'll post a video of it, or not a video, a picture of it, to show you guys what it looks like on the inside. And you can get, this is another thing, if you're refilling these, you want to make sure that you minimize the amount of debris that can potentially get in the system, because it can clog up those bars, or inside of them, those tiny, tiny holes that reside inside. Yeah, so just to kind of recap on mounting positions, always keep your pump below the highest point of the radiator, always. If you got to mount it up front, try to keep the tubes down low. This is okay, just be wary of noise, because you can get some burbling, gurgling going on up here. Never do this, ever, for any reason, ever. Ever. Never do this. Optimum, preferable position is on top. Either, for whatever reason, having the fan blow down through the radiator and out the case, or having the fan mounted on this side. Again, preferable. If you're going to be mounting it on top, you'll optimally want your fans like this if you're blowing air down into the case. If it's on top, you'll want it discharge side blowing up. And this is kind of nice, because if you have good flow inside your case, you're not going to be generating a lot of heat inside the case, really. If it's a large open area with plenty of space, you're not going to have a lot of heat generation on the inside. So let that cool air come in, let these fans pull the air up, and then there you go. But yeah, so keep it mounted like that, preferably, where it's just discharging, because these radiators do generate some heat. That's the thing that I don't like about mounting them up front. Even though People will say it doesn't cause an issue, and it really doesn't. If you've got good case flow, there's not going to be a buildup of heat. But I just don't like the idea of discharging the radiator, which is by design is to remove heat from the cooling system and put heat in the air, drawing air that's now heated into your case, even though it's not going to cause a big deal. You may not even notice a change in perceivable temperatures of the motherboard or any of the components on it. But for me, because I'm OCD, I like having it draw the cooler case air out through the top. And again, you could do the double to where you can have the fans, one mounted here, one mounted on top, have lower RPM, still maintain the same airflow, still maintain the same amount of cooling ability, just with lower decibels, less noise. That's about it. If you guys have any questions about anything, if you have problems with your system, problems with cooling, please feel free to comment below and ask away. I love helping people. That's part of the reason why I started the automotive shop. I love fixing things and love solving problems. It's something that gets me through. So yeah, please feel free to leave a comment below, ask away whatever issue you're having, and either myself will comment or another commenter will come in and lend some assistance. But yeah, that about wraps it up. Again, stand by for a video I'm going to make about fans. I have quite a few different fans that I've tested, different styles, static pressure fans, case fans for CFM. Just stand by for that. And as always, thank you for watching.